Okay, so we're going to find the domain of this expression. So you have to take care of two things, right? You have to make sure that the denominator is not 0. And also this right here, it's a radical square root. So we want to make sure it's positive. So first thing, I want to make sure that this is always greater than or equal to 0. Now, because it's in the denominator, of course, we don't want it to be 0, but it's okay because of the 2 right here. So let's see, when is it greater than 0? Well, whenever x is greater than 0 or equal to, this is fine. Which means that if you draw this on the real line, just for the square root, starting at 0 to infinity is fine. But now if you look this as a whole, this entire piece, 2 minus square root of x, well, you don't want that to be 0. So we don't want 2 minus square root of x to be 0. And then you can solve for it. Well, when will this be 0? I can add the square root of x to both sides. So 2 cannot equal to square root of x, square both sides. So you know x cannot equal to 4. So it has to be greater than 0. And also, when you come close to 4, it cannot equal to 4. So the domain is all of this. So in interval notation, we can write this as including 0 to 4, open at 4, and then from 4 to infinity. That's the domain of something like this. So we have to take care of two things. One, the square root is positive, and two, that everything under everything in the denominator is not 0. So you take care of both conditions. Let me know if this makes sense. So any questions how we got this answer?
No, this makes sense. Okay, because I was kind of I get confused with the radicals too sometimes. This
Show
makes
you
so
one
just make
more.
sure the radical's always greater than 0. If it's
Uh-huh.
okay.
Exactly. So let me give you another one so that we get an idea of how to work with this.
Okay.
Because there's so many variations, right? But really have to
Yeah.
understand this. So if no one else has question, I'm going to give you guys another problem. So let's find the domain of, let's say you have some function. Now let's talk about function where you have a square root of 2x minus 3. I want to know what is the domain of this function. So take a couple of seconds, write down your ideas, and then I'll show you how I would do it. So we're going to work out this one now. So you want this quantity right here to be positive, or it could be 0. So I want 2x minus 3 to be greater than or equal to 0. And then I solve it, right? So I would add 3 to both sides. So that's 2x greater than or equal to 3, divide by 2, and that gives you x greater than or equal to 3 over 2. So that's your domain. But of course, you want to write it in interval notation. So let's draw it first. Here's our real line. Let's say 3 over 2 is right here. And close circle, because it's okay to be 0 and everything greater. So this is our domain of this function from 3 over 2 to infinity, including 3 over 2. So that's using interval notation. Okay, so good job. Let me know if that's okay. Now here's another twist. Let me see if you guys can answer this one. So say I give you another function, say 5 over a square root of 2x minus 3. So it's very similar to the previous one, but now I pushed the radical expression on the denominator. So let me know, how would you think about that? So for this problem, you had the radical expression on top, right? So you can think of it as this is perhaps over 1. So you just need to make sure this is greater than or equal to 0. But now if you put the same or something similar like this, where the radical is in the denominator, now it doesn't matter what's on top. It could be a number, it could be another polynomial, but we just need to take care of the radical expression. So we make sure that this quantity is strictly greater than 0. So remember, we don't put the equal to anymore, because if it's equal to 0, then we have 5 over 0, and that's a problem. So you solve 2x minus 3 greater than 0. Then you get the same thing. X is greater than 3 over 2. So this means that you can look at everything greater than 3 over 2 to infinity. So open circle here and to infinity. So the domain of f is going to be open 3 over 2 to infinity. That's the domain of this function. So note the difference. If the radical is on the denominator, then it cannot be equal to, it's strictly greater. Whereas this one, if the radical is on top, then it's greater or equal to. That's the difference between having the radical in two different places. Let me know if this makes sense.
Okay, so if it has a number on top, it's just like greater than, or it's just greater than.
Right, so the number on top has nothing to do with the domain.
Okay,
You can completely
but
ignore
like
that.
this for the sign, it would just be greater than.
The sign is just greater because you
Okay.
cannot have 0 on the bottom.
Okay.
Right, so Matthew, welcome. Let me know if anyone has any other questions. So for center, you need x and y coordinates, right? So you need your x coordinate and y coordinate. So x coordinate is this one right here. So that's 2. And the y coordinate is this one, but it has to be opposite of that, right? Because the negative sign belongs to the formula. So this would be -3. And for the radius, it's r. So this number right here is corresponding to r squared. So to find r, we would have to solve this. So you take the square root, you'll get r equals plus or minus 7. But of course, the radius cannot be negative, so you ignore the negative sign, and it's just past 7. So that will be your radius. So let me know if this was something that you were asking, Matthew. Okay, so we want to find an equation of the line passing through the point 2, -1, perpendicular to the line 10x minus 5y minus 12 equals 0. So I want to borrow the slope from this line. So you want to write this in y equals mx plus b form. So let's do that. We will, so you can do it in many different ways. I'm going to go ahead and add 12 and add 5y to both sides. So that gives me 10x is equal to 5y plus 12. And then I will divide both sides. Wait, hold on, sorry. Why did I do that? I backtrack. I don't want to do that. I just want to isolate y. So I will just add 5y to both sides. So keep the -12 on the left side. So this is what you get. And now I can divide both sides by 5. So I have 10x over 5 minus 12 over 5 is equal to y. And if you simplify this 10 over 5, that's 2x minus 12 over 5 equals y. So the slope of this line is right here. That's the slope. Now we want it to be perpendicular. So what do we do with this slope? What do you guys remember?
Would it be y plus 1 equals 2 parentheses x minus 2?
Almost, but we have to do something with this slope too, because we want it to be perpendicular to the line we're going to come up with.
You have to set x to 0.
No,
No.
Now, so perpendicular means negative reciprocal of the slope. So if the slope of this line is 2, perpendicular will be negative 1/2, right? You negate and you reciprocate. So this is your slope. And then using the point slope form, y minus y1 equals m times x minus x1, we can write out the equation. Here's our slope, here's our points, substitute them. So this is y minus -1 equals -1/2 x minus 2. And then you clear out the double negative. So this is y plus 1 equals -1/2 x minus 2. That's the line that is perpendicular to the line that you were given, which was this one right here, because their slopes are negative reciprocals. Let me know if you guys follow what I did.
So if it was just parallel, would that mean the slope would just be 2?
2, you're right. So the one you gave me, that was a parallel line. So this is the only difference, right? The slope. Perpendicular, negative reciprocal, meaning you flip it and multiply by a -1. Parallel means you want the same slope. So if this line has slope 2, the line you will create will also have slope 2. Jasmine, does this answer your question?
Yes, thank you.
Sure, no problem.
I have another one.
Go ahead. Yeah.
Can we do it's like multiply and simplify. It's radical y and then parentheses 2 radical y minus 7 over radical y and then close parentheses.
Okay, so we're gonna simplify this. So when you see something like this, my recommendation is to rewrite these radicals as an exponent. So do you guys remember what's the exponential form for radicals or the square roots?
Was it y squared?
No. It's a,
Sorry, I'm just looking through my.
So this you can write it as 1/2 power, right? The square root means it's a power of 1/2. So this is 2 times y to the 1/2 minus 7 over y to the 1/2. Now, if you want, you can also bring this to the top, make the negative exponent. So you'll have y to the 1/2, 2 times y to the 1/2 minus 7 y to the -1/2. Let me know if this makes sense. I'm just rewriting. And now I will distribute. So when you're distributing, you have to use laws of exponents. So remember, if you have, let's say, x to the n power times x to the m, you guys remember what do we do here?
We add exponents.
So you have n plus m. That's the idea here, except that your exponents are fractions. So you have to work with LCD if they don't have same denominators. So let's go ahead and distribute. So y to the 1/2 times 2 times y to the 1/2. That's 2 times y to the 1/2 times y to the 1/2 minus 7 times y to the 1/2 times y to the -1/2. So that's what it looks like when you distribute. And now here it's multiplying at the exponents. Second term also multiplying at the exponent. So I get 2. So y to the 1/2 times y to the 1/2. What's the exponent for the y? You add them up, right? 1/2 plus 1/2, you'll get 2/2, which is 1. Or you can just ignore it, right? And for the second one, you'll have 7 y to the 1/2 plus -1/2, that's 0, which means y term will disappear for the second term. So that's your final simplified answer. So let me know if this makes sense.
Yeah. Okay. Okay, I see.
You see it?
I got confused with the exponents.
So when you
Add-
see radicals, rewrite them as a exponent and then follow through with laws of exponents.
Okay.
Good. So,
Thank
no problem. So our next question is a question from section 2.4. So 2.4, I believe we talked about average rate of change and net change.
Oh wait, sorry to interrupt, but I
Uh-huh.
didn't mean to write 2.4. I meant to write 2.3.
2.3. So 2.3, we did information from graphs, right? So some of the key components are finding domain range just by looking at the graph, and then finding increasing, decreasing, and local extrema. Those are the big points. And then you can also compare functions if you're given more than one graph. Now, which part do you specifically want to see?
I want to go over how to find the domain and range for a graph.
Okay, so let me see if I can find a question. Okay, so let's start with part B. So by looking at this graph, what do you guys think? What will be the domain for this graph?
Would it be -4 and then comma 2, close parentheses?
No, the graph also exists here. So that means it doesn't stop at 2. We have to continue on.
So it would be -4, close parentheses, and 4 close parentheses.
Exactly. So although you might say, okay, there's a break here, but there really isn't, because the graph picks up on the next loop, right? So
Yeah.
you stop right here and then it continues to pick up. So the domain will be all the way from -4 to 4. There's no break. If I had a break, maybe, so let me illustrate another graph. So maybe I give you a graph like this, right? And then I maybe 2 here. And then I don't have any more graph. At 3, I start again. Then you break it up into different pieces. But for this one, we don't have to, because the graph continues to exist all the way from 2 to 4. So for -4 to 4 will be the domain. Matthew, let me know if that makes sense.
Yes, that makes sense. But I have a question: does that rule apply to when you have like 3 lines?
It depends if there is a break, like the one I drew earlier. Here, right, I have a break. There's no graph right here. Between 2 to 3, there's no graph. So the domain will be from here to here, and then union from 3 to infinity. So you'll join 2 different segments as your domain. Now, what about the range? What do you guys think? So for range, you look at the y values, right? The y-axis from lowest to highest. So it's here, right? All of this, the graph exists up to here. So the range is -2 all the way to 3. Now, will it be open or closed at 3?
Open.
Open.
Not really. Look at this one. You can read the graph at that point. So it's actually bracket. Although this one is open, but it doesn't matter because it is closed right here. So we have to close it. So Madison, you got it right. So let me know if that makes sense.
I'm sorry, but can you go over how it would be closed again?
So you see how for range you're looking at the y values. So once you get to 3, well, now you have to make a choice. This one closes, this one open. You have to go with where it closes. But if the left side was also open, for instance, let's say my graph was this, then it will be open at 3. But because the other end closes it, you have to close it because that point is defined at 3. That means the y value 3 does exist in the range. Does that make sense? Okay. So another way to see it, if you look at this point right here, when x is 2, right? What is the y value? It's right here, 1. It's not right here because that one doesn't read. It's undefined at that point. But when x equals -4, your y value is right here. It's at 3. So the 3 is part of the range values because it's one of the function does get to that y value. That's why 3 is part of the range. Okay. Let me know if you guys have any questions on these two concepts. Okay, Matthew, that's okay. Don't worry. All right, now, do you guys want to see any other part to this question or this? You guys can do it. So part E, all right, so let's do part E. So for part E, we're looking for the net change. So net change, we know that that is actually f of B minus f of A. That's the formula for net change. So this is your A value, and this is your B value. So I need to find their Y value in order for me to subtract them. So my f of A, it's going to be f of -1. So when x is -1, what is the Y value? Well, that's right here. That's going to be 0. So f of -1 is 0. And f of B is f of 2. So when x is 2, my Y value is right here. That's going to be at 1. So my net change, you just plug them in. So it will be f of 2 minus f of -1, which is 1 minus 0. Well, that's just 1. So that's your net change between -1 and 2. So simply use the formula from 2.4 to find net change and then average rate of change as well. Let me know if this makes sense. All right. So let me know if you guys have any other questions you would like me to go over. We still have a couple more minutes left. Okay, so we're simplifying 4 times cube root of 16. Now, cube root of 16, it's not a perfect cube, but you can find a perfect cubed in there. So some of your perfect cubes are 1 times 1 times 1, which is 1, and then 2 times 2 times 2, 3 times 3 times 3. So this is 1, this is 8, this is 27, and so on, right? There are many more, but up to 4 or 5, that's good enough. But the rest you can use calculator to evaluate. So I know I can use this one because 8 times 2 is 16. So I can put an 8 here and a 2 here, and I still have a 4 in the front. Now this will evaluate as 2 because 2 times 2 times 2 is 8. So this is a 4 times 2. Now this one right here, it doesn't simplify because 2 is not a perfect cube. So you leave it as it is. So you can write this as just cube root of 2. And then 4 times 2, I can combine that into 8 cube root of 2. So that will be your simplified answer. And you can leave it in that form. Let me know if that's okay.
Professor, I just have a quick question.
Uh-huh.
How many problems are gonna be on our exam?
I think I mentioned about 10 to 12 with parts and multiple choice and writing response.
Okay,
Mhm.
thank you.
Sure. So let me know if you guys have any question on this problem. I'm going to go with the next problem that Magda sent me. So Magda, there's like two parts to that same question. Which one would you like me to work out?
The first part.
Okay, so we're looking for x and y intercept. For the equation y equals x plus 4. So it's the same rule for whatever equation you have. So anyone remembers how to find intercepts? Let's say for x-intercept. What is the rule? So x-intercept means when y is equal to 0, right? Because it's going to cross the x-axis. So we're going to set y equal to 0, and then we will solve for x. So I'm going to set y to 0. So you'll have 0 equals x plus 4, and then you solve for it. So you just subtract 4, and you get x equals -4. So your x-intercept will be the point -4, 0, because the y is 0. That's your x-intercept. And for the y-intercept, you're going to set x to 0 and solve for y. So I go back to my equation and I solve x equals 0. So this is 0 now. So you'll have y equals 0 plus 4, which is y equals 4. There you go. So as a coordinate, this is x equals 0, y is 4. That's the y-intercept. So that's pretty much it. The rule is important, so make sure you know the rule. Doesn't matter what kind of function you're given, you're always doing this. If you're solving for x-intercept, set y to 0. If you're solving for y-intercept, set x to 0, and then solve. Let me know if this makes sense. Okay.
Yeah, it makes sense.
Yeah.
And we do the same thing with the second part of the question, right?
You said x equals 0, solve for y for the y-intercept, and then set y equals 0, solve for x-intercept.
You say for the second part of the question, they're asking about for two x-intercepts.
Because you have a quadratic. So when you solve for one of the components, you will get two values. Let me take a look at it. Okay, so here is the other part of this. You had y equals x squared minus 3. So if you're looking for the x-intercept, you do the same thing, right? You set y to 0. So x-intercept, I'm going to set a y to 0, and I solve. So you have 0 equals x squared minus 3, because you're setting this one to 0. And this is a quadratic. That's why you're going to have two values for x. You add 3 to both sides. You have 3 equals x squared. And then you solve for x by taking the square root, which means you have to put a plus and minus. So you get x equals positive square root of 3 and negative square root of 3. So two values. So as a coordinates, you can write this square root of 3, 0, and negative square root of 3, 0. Those are your two x-intercepts. And then do this similar thing for y-intercept. You set this one to 0, and you will get x equals y equals -3. So there's only y-intercept, one y-intercept, two x-intercepts. Okay.
I'm sorry, where you get the 0 from?
I set them to 0. I set y to 0. That's why the y coordinates are 0.
Makes sense.
Mhm. So you're always going to have to do this. If you're solving for x-intercept, you have to set y equal to 0, and you're looking for the x coordinates of that point. And like I said, for the y-intercept, you do the opposite. So in this case, you're going to set x to 0, then you solve for y. So you'll have y equals 0 squared minus 3. You have y equals -3. So as a coordinate, x is 0, y is -3. So there's only one y-intercept. Okay.
Yeah, I got it now.
Okay. All right. Any other questions? All right. So I'm going to stop here, and I'll stop the recording as well.